Hello everyone, today we are going to determine the constant term in the expansion of x minus 2 over x squared all to the 9th power. So what do they mean by constant here? Well, a constant is just any value that doesn't have a variable in it. So when you expand this, you're going to get a bunch of terms, and we're going to try to find the one that doesn't have any variables in it, just an integer. So yeah, that's what constant means. Like 23 is a constant, 4 is a constant, negative 243 is a constant, but 3x is not a constant. So yeah, that's basically what a constant means. Now there are several ways we can expand this. First, like the most stupid way to do it, I would say, it's just to make a huge 10 by 10 box and just multiply everything out. But that's obviously not very smart. We can also use combinations, but that's way too tedious. I think personally the easiest way to expand a binomial like this is to just refer to Pascal's triangle. Right? You can see we are raising it to the 9th power, which means we're going to refer to row 9 of Pascal's triangle. Now, keep in mind that the first row is actually row 0, so we actually have to count down 10 times to get to row 9. And when we get down there, we can find that our values are 1, 9, 36, 84, 126, 126, 84, 36, 9, and 1. So we're going to write the coefficients right here. Write it out right here. So 1, 9, 36, 84, 126, 126, 84, 36, 9, and 1. Now we have a regular pattern to follow for the expansion of a binomial such as x plus y. So in the expansion of x plus y, which is the very basic binomial, we have 9, it's to the 9th power, so we're going to have 10 terms. Remember, the number of terms is always one more than the power. So right now it's to the 9th power, so we're going to have 10 terms. The first term is always going to be x to the nth term. Right now n is 9, so the first term is going to be x to the 9th, and the last term is always going to be y to the nth power. And as I said before, n right here right now is 9, so the last term is going to be y to the 9th. Now, I don't know how much space it's going to take up, so I'm not going to write y to the 9th right now. So x to the 9th, and the next term is, this is a coefficient. Bring the 9 over. And the power for x is always going to decrease by 1 when you go down the terms. So our first term is x to the 9th. So now we have 9x to the 8th, y to the 1st, but since it's to the 1st, we're not going to write it. And then the next coefficient is going to be 36. So we'll have 36. Again, the power of x is going to decrease. So x to the 7th, and the power for y is going to increase. So in the last term, we had y to the 1st. Now we're going to have y to the 2nd. Now we're just going to go down the line. The next coefficient is 84. So 84, x to the 6th. Again, the power for x decreases by 1, while the power for y increases by 1, so it's y to the 3rd. And then we have 126, x to the 5th, y to the 4th, and then 126, x to the 4th, y to the 5th, then 84, x to the 3rd, y to the 6th, 36, x to the 2nd, y to the 7th, then 9, x to the 1st, but since it's to the 1st, we're not going to write it, y to the 8th, then we have y to the 9th. So this is the basic expansion to the 9th power for the binomial x plus y, but we are not expanding x plus y. We're expanding x minus 2 over x to x squared. So we're, of course, going to replace the y. So we're going to replace the y in all of these terms with the term we actually have, which is this, negative 2 over x squared. But replacing all of the y's is very, very tedious since there are like 9 y's to replace. So we're gonna be a bit smart here. So we're trying to determine the constant term, aka the term without any powers, the term without any variables, the term that contains only constants like integers. And our best shot at finding the term that will actually with where the variables will actually cancel out is where all of the variables are raised to the same power. So right now we have two x's, so we have an x right here, we have an x right here. We preferably want them to be raised to the same power to give us the best shot at canceling these x's out and therefore giving us a constant numerical value without any variables. And we are going to use a property of exponents. So if we have a fraction, let's just say the hypothetical fraction is x over y to the zth power, then the resulting number is going to be x to the zth power and over y to the zth power. So we're going to use that. Now, in the bottom here, we have a variable with an exponent. Now, how that works is, for example, if you have x squared and you multiply to, I don't know, the 4th power, then the 2 and the 4 multiply and you get x8th. But that's just a hypothetical scenario. So now we have that out of the way. We can now find the term that will actually give us the same exponent for both of the x's. So let's try the first one. Now this one, I'll change colors. Now this one obviously won't work because it will be x to the 8th, and the other x right here will be just x to the 2nd, and that obviously is not what we want. So we're gonna move on. Try the next one. X to the 7th, now y squared, we have negative 2 x squared. Now the rest doesn't matter, we're just looking at the x here, and we're gonna, 2 times 2 is 4x to the 4th, not what we want. So we're just gonna try the next one. We're now at 84x to the 6th, y to the 3rd. So we can see x to the 6th and y to the 3rd. Again, the rest doesn't really matter. And we can see that 2 times 3 is 6. We have 2 x's to the 6th power, which is what we want. They're raised to the same power. So it'll give us the best shot at actually eliminating this variable right here. So we are not actually going to do the math. Now this right here, again, because the exponent's odd, we're going to keep the negative sign. And 2 to the 3rd, using the distributive property, since there's a parenthesis, so the exponent here is distributed to both the denominator and the numerator of the fraction. We can see 2 to the 3rd would be 8, and 2 to the 2nd would be 2 to the 3rd will be 8, and x to the 2nd to the 3rd, 2 times 3, we're going to get x to the 6th. Now, don't forget about the 84 in the front. So 84, that's our coefficient. And now we just have to, so we have officially gotten rid of that. And can rewrite it as 84. Now we can rewrite it as 84 x to the 6th negative 8 x to the 6th. I'm going to erase all of these right there. Now the next thing we want to do is to multiply the part that has an integer with the coefficient, which means we're going to multiply 84 by negative 8 x to the 6th. Now some simple math here. 84 times 8, 672. So now we have 80. So now the 84 is gone, and now we are just left with negative 672 over x to the 6th times x to the 6th. Now that already seems simple enough, but it's still not a constant yet. Now how are we going to turn it into a constant? Well, you can see we have x to the 6th right here, but how are we going to eliminate it? Well, we can actually turn this x to the 6th to a fraction. So x to the 6th is also equal to x to the 6th over 1. As you guys might know, any number divided by itself is just itself. So x to the 6th, we can rewrite it as x to the 6th over 1. Now we have a really, really simple fraction multiplication problem. And we can see, conveniently enough, the 2x to the 6th cancel out. So, yeah, no more x to the 6th. They cancel out. And we're left with our answer, negative 672 is the constant term in the expansion of x minus 2 over x squared all to the 9th power. Thank you for watching this crappy video. I hope you learned something from it, and I hope this was helpful. Bye.